Hello everyone, my name is Abdul Rehman. I'm pursuing my PhD degree under supervision of Professor Dr. Anand Paul uh, from Connected Computing and Media Processing Lab, Kyungpook National University, South Korea. I'm going to present my research work. The title of our paper is Trustworthy Intelligent Industrial Monitoring Architecture for Early Event Detection by Exploiting Social IoT. This is the outline of my presentation. First, I shall briefly introduce my topic, and then I will explain the problem statement, research objective, and then I will elaborate about my proposed architecture, in which I will discuss about flowchart and algorithm. So finally, I will just give results and conclude my research. First of all, I shall talk about the IoT and social IoT and industrial IoT. If I'm not wrong, majority of the computer science researchers, we are pretty much familiar with the concept or idea of Internet of Things. So it is IoT as a newfangled term acquainted by Kevin Ashton for the first time in 1999. So he advised radio frequency identification (RFIDs) tag to track and tally the products in industries without social involvement. So this was the first time he used IoT. And recently, the Internet of Things turned up as a developing field that assures pervasive connections to the Internet and aims turning all ordinary objects to the intelligent things or intelligent objects. So, thanks for the consolidation of the internet, mobile communication networks, and social network has proven a great breakthrough of information technology. The ensuing paradigm is known as social Internet of Things. So we call it like social Internet of Things. Eventually, IoT has bestowed an encouraging juncture to the build powerful industrial system and application. Therefore, an extensive amount of industrial Internet of Things and applications have been entrenched and installed recently. So although the industrial Internet of Things playing a vital role in disaster attenuation, but yet the robustness is limited. Therefore, in this research, we introduced intelligent industrial smart social agent, and this industrial smart social agent ensures every IIoT object, like industrial Internet of Thing objects, to communicate and collaborate with one and all to augment the surveillance in every industrial environment. This is the problem statement which has motivated us to work on this research problem. Sorry. The catastrophes like conflagration, noxious gases, or chemical leakage, toxic smoke, and mishap due to unsafe disease from dangerous zone, etc., are very common in industrial environment. So such calamities cause colossal physical and loss of human lives. So therefore, the adroit surveillance and early event detection of such perilous events is really an important task. We must have to detect them at early stage and to avoid the colossal fiscal. This was the problem statement, and this is the objective of our research. So we have focused on three main points, like what we have attained from this research. First one is trustworthy intelligent surveillance architecture. Like it should be very trustworthy. Like there shouldn't be any uh, uh, lack of anything. So secondly, sorry, it is completely autonomous, uh, based on ISSA, the industrial smart social agent. Uh, it controls everything autonomously by without human intervention. The third and very most important point is early event detection, because if the events are detected very early, we can control it very efficiently. And definitely false alarm is also a very big problem sometimes, because with some small event, like it starts making alarm, everyone just get afraid, so we have to avoid the false alarm as well. So this is the purpose of our research, objective of our research. So I will explain about my architecture now. So well, this is our proposed architecture, and this is five layered architecture, in which, like, first layer explains about all sensor devices and other IoT devices. And here these all devices are behave socially, like they are acting as a social internet of things. But these all devices are industrial internet of things, as I have already shown in my introduction slide. Second is communication layer. So when we call it like these are social internet of things, so definitely to friendly talk or friendly interaction between these devices, they must have to have some good communication protocol. So then only it is possible to communicate with each other without any disturbance or without any problem. So in communication layer, we have advised like many communication protocols or communication means. So we can use these devices, these internet of thing or industrial internet of thing devices, they use these means to communicate with each other without any disturbance. So third layer is the backbone of this architecture, and it explains about intelligent smart social agent. What does it do in this architecture? So this intelligent smart social agent controls all the devices and their communication. So if some event happens or occurs, uh, first of all alert goes to intelligent smart social agent, and then it checks or it analyze the data whatever it receives, and make a conclusion whether there is really some event happened or not. So in the beginning, like we can see that there is a analysis module. This analysis module is based on machine learning algorithms, and it just uh, make analysis on video and like image data, like image surveillance or video surveillance data. So we are using, because we are using static cameras, CCTVs, and UAVs. So whatever the data they sense, they send to the system like a intelligent smart social agent. And if it is the small data, it will be analyzed by ISSA. So at what scenario it will be analyzed by ISSA, and what in what case it will be analyzed by the cloud layer, like the cloud services. So I will explain in my next slide, but here I will explain, like, if for example some event occurs. So at that time, first of all, ISSA will see the exact location of that particular sensor or device which has sensed the environment and sent the alert. Okay, there is some problem. So and from that particular device, the ISSA will engage all other devices, all other surveillance devices uh, within the range of 10-meter radius. And the data that will be collected from those devices uh, only will be analyzed by ISSA. But if it is a routine data and it is going to store somewhere, so definitely we will use the cloud service. So the last layer will explain about actually application layer. And in application layer we have fire brigade and ambulance, police and control room. These are the things that I have presented here, but these can be many other services as well, according to the industry or according to the requirement. So whatever if there is really an event occurs, ISSA sends the notification to the concerned authorities and control room. So, and moreover, for the first hand, ISSA engage all robots and actuators to tackle the situation. So, this was the proposed architecture. Um, this is the flow chart of our work. Uh, in this slide, we can see that the second one is emergency alert. So let's suppose some one sensor make send some alert. So the first one is like the condition, uh, types of alerts greater than equal to 2. So what does it mean by, like, here the mean is how many sensors has sent the alert, like whether it is only smoke sensor or gas sensor, or it is a UAV or static camera. What is the type of device which has, how many type of devices they have sent the alert, like there is some event is occurring. So if more than two devices they are detecting the same, or they are sending the alert, as SSA will generate alarm and will activate the robots and actuators, and alert will be sent to the concerned authorities, and at the same time the alert will be sent to the control room, and control room will check. So for example, if there is only one device which has detected the event, for example, flame or some smoke, so in that case ISSA will, instead of generating alarm, it will just engage all the devices, other devices between at the range of like 10-meter radius, and will get their data and will evaluate very carefully, and will analyze whether there is something happening or not. So an analysis module will make the image and video analysis, whereas the other sensor values will be checked by in different algorithm or different way. So if there is event detected, then again alarm will be generated. For example, like after detecting, we come to know that, oh yes, really there is some event that is detected by that particular sensor, but because of the distance or because of some other problem, other devices couldn't track that, couldn't detect that event. So at that time also ISSA will generate alarm and activate the actuators and reports and send alerts concerned authority. If there is not any event, so then the notification will only be sent to the control room, and then our process will be stopped, and the devices will start continuing, will continue the sensing the data. So this is the analysis module for fire detection. I have already explained this in previous, like there are five different type of sensors we have used. So they will be sensing the data, so the environment. So for example, if more than two will detect, then the ISSA will generate alarm. Otherwise it will just check by the control room, and then it will just stop the system. So this is the algorithm that we have used to process our system. Our system works in this way. So we can read this, or I have explained everything well in flowchart. So this is the result that I have got from after implementation. Like in this, there are we can see that five columns, like because we have used five sensors. So gas, smoke, heat, and CCTV and UAV. So if some sensor will detect some value, definitely it will be 1. Otherwise, it will be 0. So as if continuously two any of two sensors will give one value, so it will be considered as fire, and ISSA will take make decision, okay, there is a fire, or there is a event, or whatever the situation we are going to detect. So this is also the second slide of result. In this, we have changed the sequence. So first we are going to make a visual or like imaginary image visualization of event. Like for example, we are getting the data from CCTV or UAV, and if these are detecting any value, the both are detecting any value, then the CN will be fired. Like for example, in experiment 7, I can see that there are two values. Like CCTV also has one, and UAV also has one value, and others are not being checked. Why? Because first two devices already claimed that there is some event. So ISSA will just take a decision, and will take decision that there is a fire, and other devices will not be checked. So finally I will just conclude my research work. Here we have explained the adroit surveillance. We have got the early event detection and avoid the false alarm. So our system is completely efficient in this way, because we are getting everything well on time due to ISSA and efficient mechanism. So thank you so much. This was my presentation. If you have any question, please either you can comment, or you can send me email on my email address I have given in the first page. Thank you.